make sure I can drive. Thank you for the introduction. Thanks for sticking it out to the last talk of the day here. But as mentioned, technical staff here at Lincoln Laboratory, Advanced Materials and Microsystems Group in the Advanced Technology Division. And we have a facility that was stood up about 7 years ago now that's really focused on developing these types of advanced textiles. So I'm going to give you guys an intro to our facility, high-level overview of kind of our capabilities, and a little taste of kind of what types of applications we're using this stuff for right now. So this is our facility, the Defense Fabric Discovery Center. We've actually since expanded to a couple other spaces within the lab to house all of the breadth of equipment that we need to kind of really make this stuff happen. But we are a rapid prototyping, end-to-end prototyping facility. So we're really taking a lot of these concepts from soup to nuts, working across the group and the division as a lab as a whole to really solve some of these important problems. So it starts with CAD modeling, kind of getting that concept idea started. We can take it through to building fiber and yarn devices, textile integration itself, and finally system integration and really testing it. Some of these even make it out to the field and have qualifications in that sense. It's a collaborative facility. It was stood up in partnership with AFOA, the Advanced Functional Fabrics of America Institute, as well as DevCom Soldier Center down at Natick, and built up with both federal and state funding. So there's a lot of groups involved and invested in kind of the success of the work we're doing here, and it's really grown over the last, as I mentioned, 5-7 years since we've been started. So when I say functional fabric, probably wondering what I'm talking about. Basically, kind of the core technology, or one of the core technologies that we developed. It was about 20 years ago that some breakthroughs in materials and manufacturing processes began to enable us to integrate electronic functionality into textile type fibers. So on the left-hand side, you'll see here a traditional textile fiber. This is an SEM micrograph cross-section. You can see it's a single material, polymer, fairly simple architecture, uniform cross-section, limited functionality. With this breakthrough in materials processing and manufacturing, we're actually now able to integrate multiple materials into that same type of cross-section. So on the right-hand side is a functional fiber. Here we have metals, semiconductors, insulators, all integrated into that same space. You'll notice the kind of squares. There's 8 of them. Those are the metal. There's 2 rings of semiconductor, all within this insulating material cladding, pulling it together. This specific fiber senses light and directionally where the light is coming from. But we have a whole kind of breadth of different types of functionality we can impart now that we have this ability to add multiple materials. You'll note these are kind of similar size scale factors. The functional fiber in this picture is slightly larger than the traditional one, but ultimately working towards getting our functional fibers size, scale, and integrated into fabric is kind of the goal of where a lot of our projects are going. So again, traditional fiber is kind of mainstay of the textile industry, and here we can now add potentially new capabilities into those same types of form factors. So this is a nice picture that kind of shows some of the stuff we can do. This is a functional fiber with LED integrated, right, and we're threading it through the tip of a needle in terms of kind of showing that we can actually integrate these. You'll notice that while LEDs are fairly small and we can do this, there's also larger electronics that we're looking at. And so not everything can be threaded in this way, but we're definitely working towards building up a platform that can realize this vision. So the way that this stuff is made, specifically these functional fibers, is a preform to thermal fiber draw process. So if you're familiar with how optical fibers are made, this is the same kind of technology, except here we're using some different materials. Another analogy would be if you've been to a candy shop and they're making taffy. It's a similar kind of concept of how you're stretching and pulling. So basically we start with what we call a preform, which is on the left-hand side in an exploded view. And this is basically a macro scale bulk piece of material. We've integrated, as you can see, multiple materials. The black is different from the red, different from the yellow cladding. We can have an advanced kind of cross-sectional architecture with channels, different kind of features all within that. That's then thermally processed and consolidated into one monolithic piece. And this is all done using macroscopic, very traditional machining tools, right? CNC mill, lathe, that kind of thing. This whole piece then gets loaded into a circular furnace, which is the red arc on the slightly right-hand side. As we start to heat this material, it starts to melt, it flow, and we're basically pulling it down now into the micron scale. So this is a really kind of elegant and unique way of translating all of that stuff that we did at the macro scale into a micro scale type fiber. And we can get kilometer length scales doing this type of this type of fabrication process, so it's very scalable in terms of getting enough length to really integrate into some sort of textile, right? In addition to, as I mentioned, not everything fits inside the fiber itself at this point in time, specifically thinking of electronics and types of sensing that we want to do maybe beyond, LEDs or simple detectors. So we've built up a suite of kind of complementary processes that also work with the drawn fiber. Here I'll highlight what we call kind of post-draw integration. And basically this is another way for us to integrate different types of sensors, potentially, usually ones that are larger than what we could put in the fiber itself. And this involves basically first drawing that fiber, getting a nice small one-dimensional thread-like piece that has our conductors inside at a uniform pitch, uniform tolerancing. We can then remove some of the cladding, add our specific sensor that we like, and kind of patch that up with a coat and cure. So again, just a kind of flavor of the different types of ways we can process and make these fibers. In addition to the fibers themselves, we also integrate these into fabrics. And a lot of different tools with which to do that. I mentioned, we've expanded our lab space within the last 3 years because of all the different types of textile integration equipment that is out there and that we can leverage to kind of reach our goals. So just a couple examples here. In the lower left-hand corner, we have wrapping and twisting, so taking one of our fibers, kind of integrating it with more traditional yarns to give it a more familiar kind of textile feel to it. Similarly, with terms of, I guess just to the right of that is weaving. You can weave our fibers into a textile, and then again here with the green lights shining up, we've actually had that integrated, our fibers integrated into a knit type structure. And this lower right-hand one also is knit. This one here on the glove has temperature sensors integrated into that. In addition to taking our functional fibers and putting those in fabrics, we also do some engineering and innovation at the fabric level by itself, right? This is when instances when we really do need like a two-dimensional type structure to reach our, function, as opposed to a one-dimensional one. And so some examples here, we have technical embroidery. So that's upper left, third photo from the left, showing some interesting traces we can do there. And then the upper right-hand corner here is basically fabric lamination. This is part of a patch antenna that eventually gets built into a larger garment type structure. So lots of capability here in terms of doing the fabric integration piece. So the next question is, what do we do with all this? So this is just a quick snapshot of our portfolio of fiber and fabric programs and capabilities. On the left-hand side, we tried to organize it in terms of what we're doing with it: sensing, communication and computing, protection and survivability. And I'll just kind of highlight a couple of these that maybe are applicable to you guys might be interested in. In the upper left-hand corner is the undersea sensing project. So this is basically a single fiber about 1 millimeter in diameter, hundreds of meters long. This gets deployed with a buoy, and we're basically taking temperature, salinity measurements along the length of that fiber that we can measure and correlate with depth, and really informative in terms of things for like climate change, as well as understanding better how sound travels within the water. On the upper right-hand side, I'll highlight the audiovisual system integration type projects. So this is where we're actually integrating sensors that look outward into someone's environment. There's interest from some of the groups that we work with in terms of having those capabilities, being able to have a camera that can kind of image what we're looking at, as well as a microphone, record what you see. And all this is integrated seamlessly into a textile or a garment so that it's unobtrusively part of that system. We've talked a lot about kind of protection within the conference today, and we're working in that area as well. Lower left-hand side is a concept that we had worked on for a few years with chemical detection, where we're looking for kind of a fabric-based patch that can be worn on the individual, as opposed to kind of a larger piece of bulk equipment that people have to kind of carry around to do those types of measurements. And hypoxia detection, this project kind of falls within the physiological health monitoring. So I know there was a talk earlier today from Paula about kind of integrating that into your garments, and that is an area that we're looking at as well. So with that, I'll kind of just leave it there and open up to questions if you guys have about the technology or about what we're doing with it. I'm happy to answer whatever you have up in the center here.
I had a question about the space-based sensing arrays.
Yeah.
So am I correct in understanding that it looks like you would physically have the fiber in space to augment the receiver capabilities?
Yeah, so the idea is that the fiber itself, or the concept, is that this fiber is flexible and large. You can get large in one direction, right, and it's flexible, so we can wrap that up, deploy it, and send it out. So the fiber itself, yeah, would be in space itself, potentially towed, or as much as you can be towed in space behind a vehicle in order to make that connection. This is kind of notional too. We have a couple concepts that kind of fall into that bucket. So I'm speaking about it fairly broadly at this point. There's a question over here.
Yes. The audio video sensing integration, is that detectable by a metal detector?
It depends on, what you're using to detect it. What we're using right now for a lot of our conductors are copper. So in that sense, yes, a metal detector would likely pick it up if it, but I understand where your question's coming from, and those are things that we're also thinking about, I'll say. Here?
For the dive communication, is the 3 meters like the absolute longest tether that you can attach?
No, this is more, this picture in this sense is more notional and kind of what we envision as a concept. The idea behind it we're really thinking is that, having this tethered fiber, it's small, lightweight, one-dimensional, and it can get to the surface to kind of transport across that water-air interface, which is often, with the communication, a place that can be tricky.
Thank you.
Is it like a live transcript with audio, video, or is there a place to store the data?
Are you talking specifically about the diver?
No, sorry, audio, video collection.
Yeah, so in the designs that we put together here, the data is stored on the system and then downloaded after the fact. And I guess I'll say with all this stuff that, we had specific requirements that we were designing to with our project, and that's not to say that that's the be-all and end-all of what can be done. So if you have something that you're interested in exploring or want to know more about, please come talk to me. It'd be great to kind of hear your use case that you're interested in and if we have a capability that could help. Great, thank you.